Yeah, let people come in and then we can start. Good evening, everyone, and welcome to today's talk by Dr. Divya Panicker. This is a series hosted by the Marine Mammal Research and Conservation Network of India. Divya is an oceanographer and a marine mammal researcher. Her research focuses on large cetaceans, bioacoustics, soundscape ecology, distributions, and the monsoonal influences in the northern Indian Ocean. Of particular interest to her are the waters of the Lakshadweep archipelago and the southeastern Arabian Sea. She completed a PhD from the University of Washington in 2022, during which she studied cetacean community compositions and their distributions in the Lakshadweep archipelago. She has also in the past studied the humpback dolphins in Kerala and assessed their space use patterns within the Kochi estuary. So as you can tell, she does a lot of interdisciplinary work and she is interested in long-term studies that track changes in marine ecosystems, including how large-scale oceanographic processes influence the movement and behavior of whales and dolphins. In addition to her research, Divya is also involved in ocean education and outreach. Inspired by the sea, she has co-authored children's books, Razia Learns to Swim, and Have You Ever Heard a Whale Sing? Today, she will be speaking about her work in the Lakshadweep Island group using bioacoustics. So make sure that your speakers are on. And yeah, Divya, the screen is all yours. Oh, yes. Two things. Please be muted while she speaks, and we'll be taking questions at the end. So you're welcome to ask them yourselves or leave them in the chat, whatever suits you. Yeah. All yours, Divya.
Thank you very much, Mahi. Thanks for that lovely introduction. And thank you all for making it today. I know it's a Saturday evening for many of you, and really appreciate all of you joining in. So today I'm going to be talking to you about underwater soundscapes in Lakshadweep. And if you have, as I go through, if you do have any quick clarifications or something that requires a very short answer, feel free to ask, switch on your mic and ask. But if you want to speak a little bit more in detail, then we can wait till the end of the talk. Right. So why do we really use sound to study the oceans? And I'd like you to have a look at this picture that shows different zones of the ocean and tell me what you observe about. Anyone who's brave enough to put on their mics and just share their thoughts. Right, so I will continue. So mostly if you notice in this picture, the sunlit area is right in that sliver on the top of the ocean, right? So up to about 200 meters, you have what's called the euphotic zone, which is where photosynthesis takes place. And beyond that, there's really not a lot of light penetrating into the ocean. And that's for photosynthesis to happen. But if you actually do go into the waters and you dive or you go swimming, you will notice that past a few meters, maybe on a very good visibility day, you could see 15 meters or so, or 20 meters. But Beyond that, it's really difficult to see. And the average depth of the ocean itself is about 4 kilometers. So there's a large section of the ocean which is dark. And so how do animals really find their way around, communicate, uh, find mates, and so on? So what they have done is taken advantage of another sensory modality, which is sound. So sound actually travels about 4 times faster in water than it does in air. So hence it also travels further. And animals use this sensory modality primarily to communicate, to navigate around, and to find mates. So this also becomes a naturally effective tool to tap into for us to study marine animals. So how do we use sound to study animals? So we use a methodology called passive acoustic monitoring. There are several different ways you can use sound, but in this talk, I'll be talking to you about passive acoustic monitoring. And what that means is we basically put down an microphone underwater and listen to whatever comes our way. So we're basically eavesdropping underwater. And when you actually look at fixed recorders or fixed microphones or hydrophones under the water, there are some interesting advantages. So one is that it's non-invasive. So we are not really, we are not using a boat or actually putting any sound or any human interference into the water. The second is it can give pretty high temporal resolution. So you can actually record during the night periods or during rough weather season, like the southwest monsoon, when it's really challenging to go out and do visual surveys or certain other kinds of surveys. And you can detect animals when they're underwater. So you don't really have, especially when it comes to marine mammals, you don't really have to wait for them to come up to the surface. And it's cost effective, and I put the term relatively because it is, some of the recorders are pretty expensive, but for the amount of data you get back and after the capital investment, the amount of years you can put it out, it actually for us to detect them. And often, if you keep them, if you keep the recorder monitoring continuously, you end up with very high volumes of data. So you get terabytes and terabytes, and soon it just really explodes. And what that means is post-processing can be pretty heavy, and analysis can be a steep learning curve with very high rewards at the end. So what really is a soundscape? And in this picture, you'll see several different colors coming from different sources. And if you look at the blue ones, they are what we call biophonic sources. So they're basically all kinds of sources that biology puts out. So whale sounds, fish sounds, shrimp sounds. And then we have what is called geophonic sources, which is sources that is from the earth. So you have sound from earthquakes or weather like wind and rain. And you have human generated sounds like, which is called anthrophonic. So a mix and a mix of all of this in one area is what actually constitutes the soundscape. So there may be all these different sources or some of them in different degrees. So what kind of things can studying underwater soundscapes tell us? One is it can tell us distribution, diversity, and migrations of individual species or even communities. It can give you hotspots, not just spatial, but also temporal. and behavioral insights, if you know what behavior a sound is related to, and ecological interactions, especially those that are sonic mediated. It also helps you monitor habitat quality. So sometimes a more acoustically complex habitat is a more rich habitat. And it allows you to look at a different perspective on how humans may be disturbing ecosystems or animals. So this is a study that was done in 2005, which was quite eye-opening at that point, which was that fish larvae that float around in the pelagic oceans actually use the sound of a reef to navigate and settle on the reef. So there's a lot we don't know about fish dispersal and larval dispersal, and this was very interesting that they were actually responding to the sound cues or the sound signature below 570 hertz. So what this also showed was it was not just the natural sounds of the reef, but what the spectral content, what frequencies actually determined what fish were coming back to the reefs. And then there were studies looking at how disturbances can impact reefs. So you have, as the climate is changing, you have more extreme weather, you have cyclones, more coral bleaching, which degrades the habitat. And this actually also changes the acoustics of the habitat, which in turn can actually reduce the recruitment and lead to habitat degradation again. So there's this acoustically mediated feedback loop also that people have found. And there's also work in progress to see how these disturbance events actually change the acoustic signature of the reef directly also, not just indirectly. So this is a very different perspective on how things may be changing, in addition to the ones that we already know. So most soundscape ecology studies have happened so far in the North Pacific, Atlantic, and near Australian waters. And of course, we need more information from the Northern Indian Ocean, especially the Arabian Sea, given how dynamic and interesting our oceanography is. So we do have seasonally reversing monsoon winds and currents. And the Lakshadweep Islands are pretty well suited to understand this because of the high monsoonal influence on these coral atolls. So there's about 35 islands in the Lakshadweep archipelago. They're coral atolls with very steep slopes surrounded by deep open ocean waters. There are several different microhabitats for several species, and it's an extremely rich habitat. And in addition to the monsoon currents, there's also topography-induced upwelling and eddy systems as well. So the aims of our study was to first identify and describe the major soundscape components, understand some of the temporal and oceanographic drivers or potential oceanographic drivers, and then also look at megafauna and understand temporal variability of acoustic occurrence of odontoceans. And this area is also very rich with marine mammals. So it is actually an important marine mammal area recognized by the IUCN. So we put 2 sound traps on 2 sides of Kavaratti Island from Jan 2019 to 2020. It was diver deployed. One was at 11 meters and another was at 18 meters. And it was recording from 20 hertz to about 48 kilohertz. And we recorded on a duty cycle, which basically meant that we didn't record continuously. We recorded for 10 to 15 minutes every hour. So the analysis framework that we used was, first, we looked at long-term spectral averages, which is just a really quick evaluation of long-term data sets. So we can look at a large chunk of data very quickly. And then we identified acoustic bands of interest and tried looking at what those sources may be. And then we extracted those bands and actually looked at sound pressure level, which is a measure of amplitude and how that varies over time. And then we did what is called wavelet analysis, which is a particularly well-suited method to look at temporal patterns. That's how sound pressure levels may change over several different temporal patterns at several different scales. And it accounts for discontinuities and sharp peaks. And then we picked out some of those from the wavelet analysis and looked at the particular times, like diel, lunar, seasonal, what comes out as significant. And then we actually looked at how these sources are correlated with ocean variables using generalized linear models, using sea surface temperature, sea surface salinity, and so. So the methodology is there in these papers that I have given at the bottom, and I'm not going to go too deep into it, but just to give a broad view of how we went about the analysis. So what acoustic bands of interest did we find? So first, we found right at the bottom. So here I want you to pay attention on the x-axis as well as the y-axis. So because they do change across these plots. So in the first one, the x-axis shows about 8 hours and the y-axis shows from about 20 or 0 hertz to 1 kilohertz. And in that 20 hertz to 100 hertz, you could hear a lot of wind-driven wave noise. So I'll just play that for you. I hope you can hear it. It's very low frequency. I've amped it up, but it may still be pretty low. Not quite sure if you all heard that. Did anybody hear it? You can just raise your hand. Okay. Somebody did. That's great. It is very low frequency. Then we found sounds in the 200 to 600 in the 200 to 600 hertz. So here, if you notice, the y-axis has changed. It goes up to about 1,600 or 1,000, maybe 1,800 hertz. No, 1,600. And then the x-axis is 48 hours, so it's 2 days. And there was also a high intensity around 200 hertz to 600 hertz, which based on literature is from reef fish. And I will play this. This may be a little quiet again. Try playing it again. Yeah, maybe. And did any of you hear that? can put a thumbs down. Oh, okay, some of you did, great. So this is what you're seeing on the spectrogram. This is called a spectrogram, where you have time on the x-axis, frequency on the y-axis, and the heat map actually shows the amplitude. What you're seeing is a community of fish singing at the same time. And what I've played is an individual fish song. And then we also found a chorus from 1000 hertz to 1200 hertz, which based on literature could be myctophids, reef fish, or sea urchins. And then we heard snapping shrimp, which is quite dominant in the reef, from about 2 hertz to 30 kilohertz. And our hearing goes from 20 hertz to 20 kilohertz, and that's why we heard that really well. It's that crackling sound. So we basically found 3 biophonic sources that were dominant and 1 geophonic source. We didn't find an anthropogenic source that was dominant. We did hear both, but not at the same kind of high energy levels as some of these other sources. So with that midnight chorus over here, which we had myctophids, reef fish, or sea urchin, we suspect that they're probably myctophids for a few reasons. One is that they are similar in frequency to what myctophids show in other areas in shallow waters. And they also have secondary peaks. So there's a peak around just above 1 kilohertz and then just below 2 kilohertz. And they appear to be short pulsed signals. So just to clarify, myctophids basically means mesopelagic fish. That is fish that occur between 200 and 1000 meter depths during the day, and they come up at night. And we don't think the source was from the reef because we could not really identify individual calls. So we heard the sound as a chorus, but not really identify, we couldn't isolate an individual call. And then we, as far as we know, sea urchins usually have a crepuscular feeding pattern during dawn and dusk. And here we heard them pretty much only around midnight. So, which is similar again to what has been observed in other mid-oceanic sites. And our recorders were near the drop-off. And we also have some evidence of shallow scattering layers. What that means is that layer, that mesopelagic layer coming up closer to the islands at night. So we have some evidence of that as well in Lakshadweep. So we think this may be a myctophid torus, but of course we need to investigate this further. So how do these sources actually change with season? And this is the midnight and the dusk chorus, so the reef fish and what we think is the myctophid chorus. And if you see on the y-axis, we have sound pressure levels, which is again a measure of amplitude. And it's categorized according to season. So intermonsoon, pre-monsoon, and southwest monsoon. And both the choruses reduce, they become quieter during the monsoon season. And they peaked, or rather they peaked during the intermonsoon months. So we think, I mean, from what we understand from the literature is that it's generally more challenging for egg dispersal and larval recruitment and access to shallow nearshore waters when the water is really, really rough. So we think perhaps that's why that chorus goes down. And we used sea surface salinity as a proxy for upwelling because when water comes up from deep waters, it also brings very high saline waters up to the surface, which often happens in the monsoon season. And then the low frequency geophonic sounds, of course, peak during the monsoon, as we would expect the waves to be higher. And it was highly correlated with wind speed. So what we found is when there were consistently high wind speeds above 5 meters per second in the southwest monsoon season, there was almost a 12 dB jump in sound pressure levels. So this becomes important when you think of things like masking, for what the actual acoustic environment may be for animals at that time as well. So this is a temperature and salinity diagram. So you have salinity on the x-axis and temperature on the y-axis. And the density as lines, it's going from low density to high density. And what you see is often what happens is you see these clusterings on these maps, and that shows different water masses. So here, that's actually deeper water coming up to the surface in the monsoon season. So we can see even in the oceanography, very stark changes. And when we looked at correlations, we found that higher sound pressure levels for the dusk-fish chorus was negatively correlated with sea surface salinity. So what that means is when the stratified conditions, what that means is when there's not a lot of mixing in the water, there's a lot more sound from that chorus. Lot more sound pressure levels or lot more sound intensity. So the significance of this is, one, we have a baseline to start comparing future studies. It's not enough, but it's something. And then we get information during monsoons and night periods, which is not there. So if you see, a lot of those choruses were at night. And of course, it also is linked with when visual means are not available for fish as well. And these are also challenging diving conditions. So it's difficult to do surveys on fish at that time. And it sort of gives you a peek window into what may be some of the key community biological processes that may be happening on the reef. And it situates the soundscape within what's happening locally in an oceanographic sense. There's no dominant anthrophonic source where it really stands out in the soundscape compared to some of the others. But there is rapidly increasing infrastructure and vessel traffic in the area. So it's going to be interesting to see how that, if at all, comes up in these soundscapes. And then we looked at toothed whales, odontocetes, and how they occurred near the Kavaratti Island. Basically, we wanted to know if they were acoustically around all year, and how their whistle detections changed temporally and spatially. And we used GAM models to look at this. So we did hear delphinid whistles year-round, and of course indicating there's a resident population likely to be of spinner dolphins, because we do see a lot of spinner dolphins near the island. And also the spectral structure of the whistles looked similar to some of the spinner dolphin acoustical information that we collected from boats with spinner dolphins around. And then if you look at how that was distributed across time. So here on the x-axis, you have hour of the day, and you have effect on the y-axis. And what is gray is night periods. The blue is dawn over here and dusk over here. And the yellow is during the day. So you can really see quite a stark dial difference where the spinner dolphins are heard, or rather the odontocetes or delphinids are heard a lot more during the day rather than night. especially at dawn and late afternoon. And we also saw a lunar pattern where they were heard a lot more at new moon periods. So we think based on their dial patterns as well as lunar patterns and the spectral content that these are spinner dolphins. And what it means is if you have year-round spinner dolphins, we know they feed on mesopelagic resources, especially when they are close to islands like these. So what that means is there are also year-round mesopelagic resources around the island. And this, similar to spinner dolphin populations in other parts of the world, this may actually be showing an inshore, offshore movement of dolphins where usually spinner dolphins are known to move offshore to feed at night and come closer to the shore to rest during the day. And we also suspect that there may be an island-associated mesopelagic community because of that chorus that we saw earlier, as well as the spinner dolphin movements, and that they may actually be coming up closer to the island during new moon periods. So that is something, an area that we want to explore further. Additionally, the dial patterns also may indicate that this for the delphinid population that spends time close to Kavaratti during the day, it may be a resting habitat. So that needs to be explored further. We know tourism is expanding rapidly in the islands, and as we have seen in the Maldives or in Goa, dolphin watching eventually becomes an activity. And that is something that we would like to try and get regulations around before a whole industry grows around it. So looking at the dial patterns, understanding the preferred habitats, designing regulations before, that extra complex layer of livelihoods and so on come into play. So for next steps, we of course have already started to expand this work to multiple sites because this work was done on one island. So we want to look at different sites and across multiple years to really verify these patterns. And then we also are very interested in understanding the slope ecology. So how these dolphins move across these underwater slopes and how their prey may be moving, what may be the inshore, offshore movements. And of course, as I said, acoustics requires a lot of post-processing as well as analytical capacity. So we are also interested in building that capacity in Lakshadweep and in the mainland. I was not going to talk about the whales, but yeah, we did see blue whales too, but I have already talked about this in several talks, so I thought I'll skip it. But we heard blue whales between May, and that is also one of the things we are focusing on. A whole bunch of people to thank, and this is not an exhaustive list. So, of course, this has been done with mammoth efforts by a whole range of people from different walks of life. So, very thankful to that. Any questions?
Hi, yes, I have a question.
Yes.
Hi, I'm Saliza, and I'm also doing acoustics in Malaysia. So I have a question regarding your deployment of your sound traps. Do you think there's a specific depth of how deep it should be to avoid hearing the waves and things like that?
Yeah, it would be better to deploy it deeper and I think the wave sounds will change. Right now it's pretty shallow, about 11 to 18 meters, and there is a slight difference in the different sites between, because one recorder was at 11 meters and one was at 18 meters. So in the non-monsoon months, there was a difference in the sound pressure levels, but in the monsoon months, it was the same. So I would think as we go deeper, the wind-driven wave noise would be lower.
All right. Thank you so much. And great talk. Loved it. Thanks.
Everyone, if you can just turn on your videos and ask questions or type them. But yeah, it would be nice to see everybody's faces now. Any more questions?
Hi Divya, Ameya here. I had a question regarding the larval settlement slide that you presented. So in that, you said they had a control setup with a silent reef. So I was wondering how the silent reef works. Is that like an artificial reef that they set up, or are there some reefs around the world that are known to be silent?
So maybe I wasn't clear on that. So what they did was they had playback speakers, and they were looking at, I mean, I don't remember exactly the way they had set up and where exactly they had put the playback speakers, but they had nets and playback speakers, and one that was playing out natural reef sounds from that area, in the sense from a nearby reef, and another one where they didn't play anything. So that's what I meant by a silent.
All right, got it. Thanks.
Yes, anybody with questions?
Hi, I'm not sure if you can see me, but
Yes.
thanks for the talk. That was very, very good. I'm Cindy. I'm originally from Malaysia, but I'm right now doing my PhD. I want to know maybe you mentioned it or it's in your paper, but how did you get your salinity and turbidity data? Can you share a little bit on that?
So we didn't look at turbidity. We looked only at sea surface salinity. I can't remember if I mentioned sea surface, but yeah, we looked at sea surface salinity from satellite data.
Okay, great. Thank you.
Yeah.
Divya, I have a question which perhaps I don't know if were you do tuna make any sound, and were you able to capture any of those schools of spinners plus tuna on that slope? Would you know?
At this point, not really, because we could not really. I mean, we can tell the difference between the dolphins and fish, but we couldn't ground truth with the fish. So we could look at it at a community level, and most of it seemed like reef fishes from what I have seen in other papers and in other areas. But yeah, with tuna, I'm not sure how much of tuna is contributing to it. Or if they do, what kind of sounds they make, or if they do at all.
I'm just interested in how tuna and dolphins find each other. Perhaps because they hang out
That's a
with each other.
really cool question. And yeah, it seems like tuna may be faster. That's what I could understand. So yeah, no idea.
Okay.
I don't think there are any questions. Yeah.
Yeah. Thank
Thank
you.
you so much, Divya. This was a
Yeah,
very
so if you have any questions, I can just put my email ID in the chat or something. So feel free to get in touch. Sorry, I think I have those.
I think there's one question. I'll just read it out. It's by Madhushri. Can you give me any specific example of on how soundscaping directly would help in marine conservation? I'm sure you would have mentioned a few, but it would be interesting to know more.
Right. So, I mean, one example that I didn't go into is it helps to monitor habitat quality. So that may be one way you can actually look at marine conservation. Like if you're restoring a coral reef, you know, in addition to the parameters you look at, you could also look at how sound structure, the sound signature of the restored reef is coming up. Just from the top of my head. Yeah, you could actually look at, say, with this example, right now, at least from a dominant perspective, we are not seeing a lot of boats. So if you're going to start seeing a lot of boat noise, then that may be something to look into further for conservation. And we know there has been certain kinds of responses from fish to boats. But again, a lot more to study in that. So those are two examples. But yeah, there's another. You can look at noise pollution, how that is changing across time, ship traffic. And I think one important thing to keep in mind is that the way marine animals perceive their environment may be very, very different from us, given that they do use sound quite a lot and different frequencies. So that may be, you know, a really good way to try and understand what they are actually perceiving.
I think there's one more question from Tanmay. Do you observe any differences in the acoustic parameters of spinners from different islands compared with the data set of Kavaratti? Also, can you comment on inter-island migrations of spinners?
I haven't. So the spinner dolphin vocalizations we took from the boat, where we found spinner dolphins and recorded them at the same time, have been from all across. The ones we didn't have recorders in other places, now we do. So that's something we can look at. But again, we need a lot more ground truth data to actually come down to that species level. So that is still a work in progress to really see if there are geographical differences in delphinid whistles across different areas or different oceans, but how fine scale that can be is something to look at. I suspect there won't be too much between like the different islands over here. But yeah, we don't have data yet. And in terms of inter-island migration, I think there's definitely movement between the island. Again, we haven't really looked at movement patterns and done photo ID and so on. But from what I have read and my sense and my spending time on the islands, I think parts of the population may move, but there is also a high site fidelity, I think. So how much of inter-island movement is there is a question. But I wouldn't put that down as nil, but would also say there's high site fidelity as well. So I don't know if that answers. That's just my take.
Thank you. I think I'm done with the questions. Thank you so much, Divya.
Thank you. Thanks everyone for coming on a Saturday evening. Thanks, Mahi.
Thanks.
Oh, welcome. Thanks, everyone.
Thank you.
Yeah, I think Divya's given her email ID. Please feel free to just write to her with any questions that might come up to mind later, or read her papers. They're very interesting. Yeah. All right. Thank you so much.
Bye.
See you.
Bye.
Bye.
Bye.